So we're doing 8.2. We started last class. 8.2 talks about interest. So we had a couple formulas. We had the simple interest formula. So I equals PRT, where I is interest earned, P is the principal, which is also known as the starting value, R is the annual interest rate, and T is time in years. So then we did a bunch of examples. And then we came up with another formula. So the other formula we said, this is the formula for computing future value using simple interest. A equals P times 1 plus RT, where A is the accumulated amount or the future value. We said the future value is your principal plus your interest, right? So here we just distributed P, and we got this to be our formula, and we said this makes sense because your future value, your accumulated amount, is your principal plus your interest, and this was the formula for interest, right? So logically it makes sense. It's not that there's some sort of crazy thing you need to understand to get this formula, right? And then we started doing an example, and I think my watch wasn't telling you it's time to leave. But I fixed it. So now we'll leave on time. Okay, so let's get back to it. Okay, you assume you deposit $1,000 in an account paying 3% annual interest for 6 years. Use simple interest to calculate the future value. Okay, so we said this is our formula because we want to calculate future value. A equals P times 1 plus RT. So I went back through the question and I underlined all the numbers. And then I said, what are each of these numbers, right? So it's really important that you know the formulas and you know what the letters represent, right?
What's the other formula? I'm sorry.
So all these variables are the same. From the previous one, I just included A because A was not in there. Okay. So we underlined everything. You deposit $1,000 in an account. That's your principal. That's your initial amount, right? Paying 3%, whatever percentage you see, that's going to be your rate, right? If you ever see a percentage, that's your rate. Annual interest for 6 years. T is time in years, so we got it, right? We're solving for A. A is 1,000. That's P times 1 plus R, which is 3%. Can somebody help me write that? 0.03 times T, which is time in years, is 6. All right, so we can plug that in.
The parentheses equals 1.18.
Mm-hmm.
And then times 1,000 equals 1,180.
1,180 what? Dollars. Good. Okay, so we could do this for different times, right? So my question is this how this really works? Is this how bank accounts actually work? Is this how loans actually work? What do you guys think?
It's probably pretty good.
Nope. So this is simple interest, right? Usually your bank account and loans work on compound interest. So you earn interest on the interest is how that works. So I think I told you guys about student loans. Loans, they're charging you an interest per day, right? Per day interest based on your principal. That's a lot different, right? So the way student loans work is you're charged a per day interest, and then it's compounded per month. So student loans are compounded per month. Yeah.
So, at least in terms of getting a car, if you have, you say it's a $15,000 car. If you have $10,000 and you just want to pay $10,000 off the car, is that better because then you're going to pay less interest because the principal is less?
What do you think?
I mean, I think so.
I think so too.
Okay.
Right? If you're paying 6% interest on $15,000 or you're paying 6% interest on $5,000, the interest you're paying is a lot less, right? So I think for a lot of people when they're putting like money down for a house or money down for a car, you don't want to put all of your money you have down, right? Because you have to have a certain amount saved, especially as you get older, right? Like if you run out of money, you guys can probably call mom and dad or something, right? If I run out of money, I'm like homeless. I mean, I could call my mom and dad, but right? It's a different situation. So if you guys put all your money down for a student, for a car payment, that's one thing. But like when you buy a house, I wouldn't recommend putting all the money you have in your savings account on a down payment for a house because there are certain things you have to pay for in order to buy the house. Like you have to pay for an inspection, you have to pay for a property line evaluation, you have to pay for
Then you have expenses.
moving in. You have to, I mean, what you really need when you buy a house is like a couple $1,000 gift card for Lowe's because stuff happens. If you're like me, you want to change the toilet seats. I don't know, right? There's just stuff that's going to happen that you're going to need. So I would say don't put, plus at that point, right, right, like sometimes renting is nice because then you can just be like, hey, this is broken, come and fix it, and it doesn't cost you anything, right? But when you own a home, it's like, hey, plumber, come over, and I have to pay you $100 just to come by, not even to fix anything, right? So it's different. I mean, but if you're 20 and you want to buy a car, I say go for it. If you don't have any other bills, if you're living here with your parents, go for it. But it's always a balance between should I just pay for it or should I make sure I have some in savings? And I lean a little more towards a balance between the two. Like I wouldn't throw all my money at anything. That's my personal. But the numbers are, right, 6% interest on $5,000 is a lot less that you're paying a bank than 6% interest on $15,000. But it just depends on your financial situation. If you've got $100,000 in the bank, why not just pay for the car? If you have $5,000 in the bank, maybe put 4 towards it. That's how I would go. But again, I'm not a financial advisor, but that's my personal experience, my personal opinion. But the numbers, I can tell you the numbers, right? Okay. So the way that interest actually works is compound interest. So let's talk about that. And the quote at the beginning of this section was about compound interest, right? It's the most powerful force in the universe. Albert Einstein said that.
Was he like joking or was he serious?
I didn't ask him. So forgot to ask. I'm just joking. I don't know. It's a quote from the book. That's the only place I read that he said that. Okay. But I do think that if you understand compound interest, it can work for you, whether you're saving money, or it can work against you if you're taking out loans, right? Mm-hmm. So if you understand it, it gives you a little more power. All right, so let's do compound interest. So interest paid on the principal plus previously earned interest. So compound interest is when your interest is added to your principal and then you continue to earn interest on that. So whether it's a loan or whether it's a savings account. So let's do the formula. So A equals P times 1 plus R over N to the NT. So I'm going to write down all the variables, but all the letters are the same. The only new variable we have here is N, right? A is the same as before, P is the same as before, everything's the same as before but N. I'll write them all down though just so we have it in this section. So A is future value or accumulated amount. P is principal or initial. So again, for these formulas, we're usually talking about money, right? Before we talked about the value of a house, the value of profit from McDonald's, right? This is usually money in the bank in the form of a loan or in the form of a savings account. So that should help you distinguish between all of the formulas we have, right? So this is typically money in the bank or loans. So interest rate, what do we need to do with the interest rate?
Need to know what it is.
Uh-huh. And it's usually a percentage, so we need to change that percent to a decimal, right? So again, interest rate is a percent. So T is time in years. And N is number of times per year. Number of compounding periods per year. All right. So this is our formula that's going on a flashcard. Right? And then that's the definition of all of our variables. So let's do an example. You open a bank account and earn 3% annual interest. If you deposit $1,000 into that account, how much will you have in 2 years if it is compounded yearly? I want to see. Let's see if you guys are having fun. All right. So what? So it says it's compounded. That tells us the compound interest formula, right? So it explicitly says it's compounded. Compounded yearly, compounded monthly, compounded, we can make up a bunch of stuff, right? Different compounding periods. But it explicitly says compounded, so we're going to use the compound interest formula. If it ever says, explicitly says compounded something, compound interest formula is what you're going for. It says compounded, that means I'm going to use the compound interest formula, right? All right, so now let's go through and underline all of our numbers and see what we get. See what those numbers are. Okay? I'm going to write out my formula. A equals P times 1 plus R over N to the NT. Okay, key. So I'm going to write down all my letters. A, P, R, N, T. When I write out all these letters, go back and read, I should only have one letter that I'm not sure of, right? Okay. So A, accumulated amount. Is that in here? It says, how much will you have? That means future. Will is future, right? How much will you have? That's my question mark. Principal, that's my initial amount. If you deposit $1,000 into your account. R is interest rate. That's always the percentage. Here I have 3%. How do I write that? 0.03, sorry. N is the number of compounding periods per year. What do you guys think about that? I don't know right now. What about T? T is time in years, which is 2 years. Okay, so I need the number of compounding periods per year. So it says if it is compounded yearly, yearly is my N. So if I compound it yearly, how many times am I compounding it per year? Yearly, it means I'm doing it once. 1. So that's T. T is 2 years, but the number of compounding periods per year is N. If I'm compounding it yearly, I'm compounding it 1 time per year. Right? Number of compounding periods per year, not the total number of compounds. It's the number of compound periods per year. Okay, so let's plug all this stuff in. So A, that's what we're looking for. I have all my other letters. A equals P times 1 plus R, 0.03 over N, which is 1, to the NT. So 1 times 2. Okay, now we can plug that into our calculator, right? Let's say you have the dollar store calculator. How do I do that? All right, help me out. How do I do this if I have the dollar store calculator? N is the number of compounding periods per year. It says it's compounded yearly, which means 1 time per year. Right? So make sure you know that N is the number of compounding periods per year. Okay, so somebody help me. How do I plug this in? I have to do PEMDAS, right? So first I need to clean up inside the parentheses. 1 plus 0.03 times divided by 1 is 1.03. 1 times 2 is 2. Okay, so I did the parentheses. I cleaned up inside the parentheses. Now I do exponents. 1.03 squared is 1.03 times 1.03, right? I don't have the squared button on my dollar store calculator, but I know what squared is. So this equals 1,000 times 1.0609. Okay, so parentheses, I took care of, I cleaned up inside the parentheses, then I did my exponents. Now I need to do multiplication and division. So I'm going to multiply this times 1,000. So that equals $1,060.09. Dollars. So make sure you know PEMDAS, right? In order to do this in your calculator. Okay, now let's do B, compounded monthly. Okay, so same exact question up above. What changes from the question up above to this question? N changes. Good. So N went from yearly to now monthly. What does N represent again? No.
Number of times yearly.
Number of compounding periods per year. So if it's compounded monthly, how many times am I compounding it per year? 12. Okay. Then it's the same exact formula, right? Okay, so A equals, I'm just going to take this and make N equal 2. So I'm plugging in everything I have. Over N, which is 12, to the 2 times 12. Or 12, just do 12. Okay, this one, little trickier to do in your dollar store, right? So again, we're doing PEMDAS. So I need to clean up inside the parentheses first. 1 point, so how do I do this? I clean up inside the parentheses. Inside the parentheses, I have division and I have addition. So I need to do the division first, right? Do the division first, 0.03 divided by 12 equals that. And then I do 1 plus this. $12 times 2 is 24. So a lot of people, I will see them just type this in their calculator. 1 plus 0.03 divided by 12. Here you're only dividing 0.03 by 12. So here you're doing 1 plus, so you're not going to get it right. So what's going to happen? So do the division first. But maybe it did it right, but usually it might be funny. So do the multiplication and division first, and then do addition and subtraction, right? So you never know how smart a calculator's. Okay?
What do you want us to round to?
That's all that came up for me. So we don't need
next equation.
turn around. So I say don't round until the end. Okay. So then my phone I can turn to the side. Do you guys have a calculator?
I do.
The fancy pants? Which one do you have? Inspiration. What is it? Inspire? TI Inspire? Yeah. I think some people have the fancy calculator and some people have zero calculator. Okay, so how do I do this? So I clean up inside the parentheses. Now I need to do exponents, right? So 1.0025 to the, where's the to the on this? XY. To the 24. Okay, so that's what you get. Now you do multiplication. So now I'd multiply times 1,000. So that equals 1,061.757044. So what are we talking about here? What are my units?
Dollars.
Dollars.
Which means you only need Or do you want to round it to 76 cents? Does it matter?
Well, I know what I want to round it to if I'm the customer. I know what the bank wants to round it to. The bank wants to round it down. Me as the customer wants to round it up, right?
Right. But which one are we in this equation?
We're the one that so for this, who decides that, right?
Yeah.
Is the bank.
Okay.
So I would guess that would be a round down. Right? Doesn't work for me. I want that 0.7 cents. Okay. So let's do another one. C, compounded daily. So what's the difference between compounding daily? What am I changing from my previous example? N, again, right? All right, so I want you guys to do this one. Should we make it a quiz?
Yes.
Here you go. Here's your quiz. Take out a piece of paper. Write your first name space last name on the top right corner and show all of your work. It's open notes from your notebook only. It's not open notes from your friend's notes. Open notes from your notebook only. If you need a piece of paper, ask a friend, ask me, I can help. All right, so no more talking to your friends now.
So why don't we just do monthly, right?
So daily, the only thing that changes is N. What does N represent?
Number of compounded.
Good. So daily is how many days are there in a year, right? So write that down for your N. First name, space, last name, top right corner, very legible. So look at your notes. Don't look at your friend's notes. Fortunately, if you need to use your phone. Daily. Here's the question. you guys are all asking questions about rounding. It's money, right? So how many decimals appear in money? Use those decimals, right?
I'm saying, if you want to just nearest on that, right? Like a month. You want to just have it as one time.
It's my bank account. I want that lunch, right? I don't want Okay, so don't talk. Get your own paper. All right, if you're done, I'll take it. You want that? 40 more seconds. Did it. Pass it. Okay, good. Good night, everybody. Do I have everyone? Yes, no, maybe. Okay, if I don't have it, I'm going to go over the answer now, so you will not get credit.
Can you go over the answer? I'm so
Okay, let's do it. So the question is the same, right? Just like A and B. The only thing that changed, just like A and B, was N. The N is the number of compounding periods per year, right? Okay, so here we have this question. Just like A, just like B, which if you're taking good notes, you can just literally copy the stuff down. The only thing that has changed between A and B was N because of the number of compounding periods per year. So here we said we're compounding daily. What does that make N?
365.
Good. Because there's 365 days per year. So I'm compounding daily. So everything else is the same. A equals P times 1 plus R over N to the NT. A equals P. So I'm literally copying down all the numbers, except I'm changing N from 12 to 365, right? That's it. Right? So if you're taking good notes, you can literally just look back and just plug in, right? If you understand what N is the number of times per year. Quite a few people ask questions about what is N in this case, what is N in this case. So we have to be clear about what N is. All right. And then what did you guys get?
1,061. What do you get when you take 0.03 and divide it by 365 or whatever you do? Because I got like 12,000 or like 0.0000008. Is that right?
Okay, I can do it.
I don't know how.
0.03 divided by 365.
Yeah, is that right?
That's what I got.
Oh my god, I thought it.
Plus 1.
Oh.
So usually here it's 1 point something as a decimal, right? Here we got 1.3, here we got 1.0025, here we got 1.08.
So I just stopped at the 82. I didn't do the 19. So I got 0.68 instead of 0.3.
You got 0.68?
0.68 because I didn't include the 1 9.
Yeah, so that's why I wouldn't round until the end,
Okay.
right? If you round here, I don't know, you could even round to this many decimal places. You're not going to get much, right? So keep whatever's in your calculator in there. Right here, I would go here from this point to doing the to the power thing. What's 2 times 365?
730.
Then I would just hit to the 730. Is that what you guys are saying?
720.
I would just do that. And then that takes care of this piece. Then I would times it by 1,000. And then I would round. Keep whatever's in your calculator in there. You don't need to retype it shorter later. Just keep it in there. If you have a TI, you can even store stuff in your calculator too, right? So don't make it like this. I'm being a little lazy here, right? By not retyping stuff, but it's also more precise, which is the beauty of math, right? You can be a little lazy, and that's better. Sold. Okay. So, what if I did compounded quarterly? N would be 4 because there's 4 quarters in anything. There's 4 quarters in $1. There's 4 quarters in a year. There's 4 quarters in a football game.
Yeah,
right? There's 4 quarters. If something's called a quarter, it means 1/4. So N would equal 4. What? Well, I'm trying to think about other things that are in quarters. But a quarter means there's 4. There's 4 quarters, right? How many halves are there? There's always 2, whether it's a football game, whether it's $1, whether it's... Okay, so we're not going to do the calculations for this. What are other ways that they could ask? Monthly is 12. Quarterly is 4. Annually is once per year. What else?
Hourly.
Oh, goodness. No, I don't know if anybody's compounding anything hourly. Weekly? How many weeks are there in a year?
54.
I think we need to get on the same page about that. Okay, let's write that down. N equals, how many weeks are there in the year?
52.
Listen, daily should be 365.25, right? But I'm not getting into that one. Leap year?
Yeah, let's just
So we'll keep it 365. But if it's a leap year, it's 366, right? For daily?
let's just hope it's not leap year.
I want that money. Okay, so obviously, what can you see if you're investing your money? What do you think is the better investment?
In what?
What do you think is the best investment? If they give you a bank account, or if they give you, you can compound it this monthly, you can compound it daily, you can compound it yearly.
You want to compound it daily.
Why is that, Finn?
Every single day, next week, it giving you more.
You're getting more money, right? We just ran some numbers. You're getting more money. It might only be a fraction here, but could you imagine if it's $10,000, if it's $50,000, right? So it might be starting low, but over time it adds up, and that's why compound interest is the most powerful force in the universe, right? So this can work for you in terms of student loans, or it can work this can work for you in terms of savings account, and it can work against you in terms of student loans. All right, so let's do another example. I think this is number, I don't know what, just example. So which is the better investment? A, 5% compounded yearly, or B, 4.95% compounded quarterly. Well, let's figure it out. So, which is the better investment? So, what is it asking you?
Which is the better investment?
So, what value am I looking at in the formula? A equals P times 1 plus R over N to the NT. Well, what did we just look at to determine the better investment here? Okay, well let's talk about what we're looking at. Which letter are we looking at? Which letter did we use to determine which is the better investment here? The accumulated amount, A, the future value. If I deposit the same amount into each bank account, which one gives me the best return? Which one gives me the most money, right? Okay? So let's see. So do key. A equals, that's what we're looking for. P equals R equals N equals T equals. So I'm going to do this as A and B. So try to look at the question and figure out what information you have from the question, right? But I'm trying to solve for A so I can compare the values of A between A and B to figure out which I'm going to get more money from, right? Okay, who can help me for A? Oh, underlining what I have. 5% is my rate, 0.05. And compounded yearly is what? N. N is the number of times per year. Yearly is 1. Okay? Here, part B, my rate is 4.95%. Who can help me write that? 0.0495. Good. Compounded quarterly is what? 4 times per year. Okay, I'm missing a lot of information, right? What do you guys think about that? Who has an idea? What do I care about? I care about seeing which is the better investment, so I care about the accumulated amount.
Pick random ones, just make sure you use the same one for each.
Awesome, Finn. I can choose my principal and I can choose my time. As long as they're the same for both, then I'm comparing my accumulated value. Whether I have a $10 investment, whether I have a $1 million investment, the rate and the number of compounding times is what I care about. So if I keep P and T the same between A and B, I will get an answer. I can't choose different amounts, right? So what do you want to do, $1,000?
$100.
Let's do $1,000. So we can see. You want to do 100? Okay. For how many years do you want to put that money in? 1 year? Yeah, let's keep it easy, right? We don't need to do crazy powers. We don't need to do to the 730th power. Well, I want to make sure I can see the decimals, though, right? You have to, if it's like the previous problem was like a 10-cent difference, right? 8-cent difference. I want to make sure I can see that. So if we choose $1, we might not see it, right? All right, so plug this in. You guys do it. So you guys chose good numbers. I like it already. What'd you get for A? Huh?
It's because I picked them.
Proud of you. What'd you guys get for A? 1,050. What'd you get for B? So here I got 105.0945. What'd you get for the first one? I think it's 1,005, right? 1.05 to the first times 100. So which is the better investment?
B.
B.
Because you're getting that 4 times.
So if it's $1,000, you're going to get 90 cents more. If it's right.
You would get 90 cents more. You just need to
9 cents.
every 4 times.
Yeah. All right. So if I have your quiz, that's your attendance for today. Again, I do have office hours. If anybody has scheduling questions, I'm happy to do my best to answer. If not, I'll see you guys next week.
Thank you.
Thanks. Oh, bring a calculator next class with log. Bring a calculator next class with the log button.